A commonly held belief in popular science is that black holes explode in a dramatic fashion, similar to supernova. However, the truth is far more surprising. Black holes do not explode. In fact, they gradually fade away, quietly and without any explosive events. This revelation challenges the conventional narrative and invites us to explore the life cycle of a black hole, from its birth to its eventual death, in a way that most people would never expect. Stage 1. Birth. Whether a black hole forms from the collapse of a massive star, from a spontaneous collapse of the energy sea, or from a gravitational pressure that leads to the creation of a deep gravitational well, one thing is clear: when the curvature threshold is crossed, a black hole is born. This transition involves the locking of a 4-layer structure during the collapse. The soup core ignites and begins to churn. The crushing layer starts to tear things apart. The piston layer establishes a rhythmic cycle, and the outer critical boundary seals off the black hole. This marks the youth phase of a black hole, where it begins to evolve in a manner that makes it truly unique. Stage 2. Consumption, jets, and stability maturity. A black hole can be seen as a rhythmic engine. The soup core continues to churn violently, while the piston layer inhales and exhales, regulating the flow of energy. Jets of matter burst from the poles along the curvature corridor, and the outer critical pores steadily release pressure. This phase is where the black hole's curvature structure is most stable and most efficient. It not only governs the flow of gas within galaxies but also helps carve out the very structure of the universe, playing a dominant and influential role. It's during this stage that the black hole exhibits its true power, controlling the universe on a grand scale. Stage 3. Entering the slow boiling phase. Decline. As the accretion rate drops, the strength of the jets begins to weaken, and the churning of the soup core slows down. The black hole enters a period of gradual decline. During this phase, the piston layer's rhythm becomes shallower. As the breathing becomes less pronounced, the efficiency of the crushing layer's tearing action begins to wane. The outer pores, which were once wide and frequent, now open less and less. The curvature gradient becomes less steep, as the overall tension in the energy sea begins to loosen. This process resembles an engine that gradually slows down over time, eventually losing its ability to maintain the same level of activity. Stage 4. Curvature dissipation. End of life. The outer critical layer's continued energy dissipation, or slow evaporation, consumes the remaining curvature energy of the black hole. Once the curvature drops below a certain threshold, the black hole does not explode or release an immense burst of energy. Instead, it quietly fades away. The 4 layers, once tightly bound together, beginning to loosen. The soup core reverts to the ordinary energy sea. The crushing layer vanishes. The piston layer collapses back into the energy sea, and the outer critical boundary ceases to be taut. At this point, the black hole ends its life without any grand explosions or cosmic events. Its death is a peaceful, silent one. In energy filament theory, the life of a black hole is not a story of destruction and collapse. Rather, it is a slow process of curvature moving from extreme tension to stable equilibrium, and eventually dissipating back into the energy sea. This process is far more subtle than a cataclysmic explosion, revealing a quiet and gradual transformation. In the next episode, we will dive into the life cycle of a black hole in more detail, focusing on how it completes a full cosmic breath cycle as it evolves. Tap follow, share it on New Physics, Clear Universe.